do two things. So the first thing is to apply some mathematical functions and into some array. Okay, so we are going to import the probability distribution that we did from the task number 9, and we want to calculate the potential energy function from the Maxwell-Boltzmann distribution law. So for example, if you get a probability distribution function P, and you want to calculate a potential function, so what you can do is you can do the minus kt log P. Okay, so and then after that, after you get the potential function, you are going to do the order 2 polynomial fitting to the potential function. So finally, at the end of the day, you can get the equation of polynomial of the two order to describe your potential function. Okay. So from the task number 8 and 9, so you are going to read the same data from them. So it's the data from the 5 sample data. And after that, in the task 9, what we have done is we have done the histogram. And then we have used 20 bins for the histogram. And then we do average of the left bin edges and the right bin edges. Okay, and then to calculate the potential energy function. Okay, so let me just run this program for the first time, and here what you have for the x bin is the 20 numbers describing the x values, the domain of your histogram, and then if I type p, it is just the probability to find sample points in the bin. Okay, so and then from this array, if I try some mathematical function with the arrays, for example, if I do np sine p, it will take the sine function to all the values in the arrays of p, but this time I will use the logarithm function. Okay, so in Python, the natural logarithm is is in the command log. So this log is actually ln in our sense. Okay, so if I type np log 2, so it is just equal to this log natural 2. Yeah. So to get the potential energy function, so I just simply type u equals to minus np dot log p. Okay, so the kt we can just treat this as a unit of energy. So this we can say that it is the energy in the unit of kt. Okay, so now we just try to simply plot the potential. So we do the PLT plot, and our domain is the x bin again, and our range now become u, and you're gonna plot these as a dot. So you put the k dot in the quote, and here is what you get from taking logarithm of the histogram. So then we are going to use the two-order polynomial fitting. Okay, so here the function that we're using is using the polyfit. Okay, so if we go to the documentation, and if you search for the NumPy polyfit, you're gonna see this documentation. So what you need for the polyfit is you need the domain of your data, you need the range of your data. So you need the data x and y, and then you need to specify the degree of the polynomial. So if you want to use the polynomial of degree 2 or a parabola to fit into your graph, you just type 2 into here. Okay, so here we are going to do a simple way. We are going to use just the degree 2 of the polynomial. So what we do here is we are going to do p equals to np dot polyfit. And I will input the x values, which is the x bin. I will input the y value, which is u, and I will input the order of the polynomial, which is 2. And here is what we get for the input. So for the output. So we output the polyfit to a parameter called p. So if I type p and output it here, you're gonna be given the array of 3 numbers. Okay. So what does these 3 numbers mean? So let's have a look at your documentation again. So the p0 or the p0 or the first element of your array. That means the first coefficient for your polynomial. Okay. So for example, in our case, we will just say that this plot is fitted to the equation. And then we continue to print that it is. So we put some number format here. So this is supposed to be the first coefficient times by x squared. Okay, so this is like the second order term, and then plus a number times x. So this is the first order term, and finally it is a 0th order term or the constant. So it's just plus by a number, and then it is equal to 0. Okay, and then we're gonna put the number. So p0. Okay, so if you do p0 here, it means the first number of the array, and if you do the p1 over here, it means the second number here. That will become the coefficient of the first order term. And if you do the p2 here, it is the last number, which is the 0th order term. Okay, so if I run this, so this will give us the fact of what is the equation to fit this function. So the equation to fit to this data is 0.4 x squared plus minus 0.06 x and plus 1. Okay. So to make this looking more beautiful, so you can also plot this. You can also plot this equation into this graph also. Okay, so in this case, I will introduce you to another function. Okay, so it is called polyval. So this will calculate the value from any polynomials. Okay, so you can do the import. So in NumPy there is a sublibrary called the polynomial, and in the sublibrary polynomial there is another sublibrary called the polynomial. It's funny, but it is the way it is. And import polyval. Okay, so for detail, you can try to consult the online manual for the polyval. Okay, so what you need for the polyval is you need to specify the array x. You need to specify the coefficient c. So that is what we need. Okay, so I will do so I will firstly to create a domain which is the xfit. Okay, so this time I will try the np.arange. So maybe let's start from maybe minus 3.5. Let's end this with 3.51, and let's do this. Let's increase the value 0.01 at a time, and then for the range of the function, we use the y fit. and we use the function Polynomial, and we input a variable. We input firstly the domain, so which is x fit, and then we create a tuple or the bracket here, which contain 3 numbers. Okay, so the first numbers that we need is P2, is number from the zero, is the zeroth order term, is the coefficient of the zero order term of the polynomial, and then followed by the coefficient of the first order term, and then followed by the coefficient for the second order term. Okay, and then after that, we are doing the plotting. Okay, so then we should plot x bin versus u, and at the same and we plot this as a dot. Okay, so this is to plot the raw data. So this line is for plotting the raw data, and then another line is for plotting the fitted data, which we will plot the x fit against y fit. And maybe I'll try to change the argument into to change the color of the line into the red color, and then here is what you get for your functions. Okay, so that is the end of all the tutorials in this series. So thanks very much for your subscribe. Thank you.